Look down at your arm right now. That color was not an accident. It was not random. It was a survival decision made by your ancestors millions of years before you were born. And the real answer to why your skin looks the way it does is far stranger than anything you learned in school. You probably think skin color is about geography. Sun equals dark skin. Cold equals light skin. That is the version most people carry around. But that version skips the actual mechanism, and the mechanism is the interesting part. Go back about 2 million years. Your earliest ancestors were covered in fur, just like other apes. Underneath that fur, their skin was pale. Pale skin protected by thick hair never saw direct sunlight, so there was no reason for it to be anything else. Then something changed. Early humans started walking upright, moving farther across open savanna, chasing prey for hours under direct equatorial sun. That kind of endurance hunting generates enormous heat. The body needed a way to cool itself fast. The solution was sweat. Millions of new sweat glands appeared, and to make sweating efficient, the body gradually lost its fur. Bare skin meant sweat could evaporate freely off the surface, but bare skin also meant something else. It meant that skin was now exposed directly to ultraviolet radiation for the first time in the species' history. This created a brand new problem. Ultraviolet radiation is dangerous. It damages DNA. It destroys a nutrient called folate, which your cells need to divide correctly and which pregnant mothers need for healthy fetal development. Without folate protection, birth defects and fertility problems rise sharply. Evolution does not tolerate that kind of risk for long. So the body found a shield. That shield was melanin, the pigment that makes skin appear dark. Anthropologist Nina Jablonski, who has spent decades studying the evolution of human skin, describes melanin as a natural sunscreen, built directly into the cells of the skin itself. The more melanin present, the more ultraviolet radiation gets absorbed and scattered before it can damage what is underneath. So dark skin was not a starting point. It was an upgrade. Every human being on Earth descends from ancestors who were dark-skinned, because dark skin was what allowed the first hairless, sweating, sun-exposed humans to survive and reproduce successfully on the open plains of equatorial Africa. For a long stretch of human history, that was the whole story. Dark skin, high sun protection, everyone thriving under the same equatorial conditions. But then humans did something no other ape had done before. They started to leave. Around 100,000 years ago, small groups began migrating out of Africa, moving north into regions with far less intense sunlight. And this is where the story takes its strange turn, because the very trait that had kept humans alive under the equator became a liability somewhere else entirely. Here is the part most people never learn. Skin does more than protect against the sun. It also produces vitamin D, and it can only do that when ultraviolet light penetrates through the skin's surface. In regions near the equator, sunlight is so intense that even heavily melanated skin still lets through enough UV to produce sufficient vitamin D. But move far enough north, into weaker, more slanted sunlight, and dark skin starts blocking too much. Not enough vitamin D gets made. Vitamin D is not optional. It regulates calcium absorption, which is essential for strong bones. Without enough of it, bones weaken and deform, a condition known as rickets. It also plays a role in immune function and reproductive health. In low-light environments, a population with too much melanin was quietly at risk of long-term nutritional deficiency, generation after generation. So evolution adjusted again. In populations that settled in northern latitudes, natural selection began favoring individuals with less melanin because lighter skin let in more of the limited ultraviolet light available, allowing enough vitamin D to be produced even during long gray winters. Over thousands of years and multiple independent genetic mutations, populations in these regions gradually became lighter-skinned. Geneticist Sarah Tishkoff, who has mapped pigmentation genes across African populations specifically, found something that upends the simple black-to-white narrative even further. Skin color across the African continent alone shows enormous genetic diversity, shaped by local sun exposure, altitude, and diet, not by a single fixed rule. Some of the very genetic variants linked to lighter skin in Europe and Asia can also be found, in different combinations, within African populations who live in regions with different sun exposure patterns. In other words, skin color was never one dial turned from dark to light in a straight line as humans moved north. It was, and still is, a constant biological negotiation. Too much melanin in low sunlight risks a vitamin D deficiency. Too little melanin in high sunlight risks folate destruction and skin damage. Every population on Earth landed wherever that balance made survival most likely, given exactly how much sun their environment provided. Researcher George Chaplin, who worked alongside Jablonski mapping global skin color against measured UV radiation levels, found that the correlation between the two is remarkably precise. Skin pigmentation across the globe closely tracks the amount of ultraviolet light a region actually receives, almost like a biological readout of local sunlight intensity written directly onto the human body. This is not a story about one group of people being more evolved or more adapted than another. Every population involved was equally successful. Every shift in pigmentation, lighter or darker, was simply the body's best available answer to the specific light it was standing under. Dark skin was never primitive, and light skin was never an upgrade. Both were precision instruments, tuned to two very different environments, thousands of years apart. And this process did not stop in the ancient past. It is still visible today, still measurable, still happening in the way modern humans respond to sunlight. Spend a week at the beach and your skin darkens. That is not a coincidence, and it is not cosmetic. It is your body running the exact same emergency response your ancestors relied on, activating melanin production the moment it senses rising ultraviolet exposure, protecting the folate your cells still need, using a system built over 1 million years of trial and error. Meanwhile, people in far northern countries are frequently told by doctors to take vitamin D supplements through the winter. That single recommendation is a direct descendant of the same pressure that lightened skin tone in northern populations thousands of years ago. Your body has not stopped solving this problem. It has simply been solving it for so long that you never think to ask why. So the next time you catch a glimpse of your own skin, in a mirror, in sunlight, in a photograph, you are not looking at a fixed label. You are looking at a live report from your ancestors, a running calculation of exactly how much sun they needed to block and exactly how much they needed to let in to keep every one of their descendants, all the way down to you, alive long enough to keep going. Your skin was never black or white. It was always a measurement.